I've been obsessed with quantum mechanics since I was a student. This spooky, strange model of the world accurately predicts the behavior of everything around us. Like the entire periodic table, the double helix structure of DNA, or the way that transistors work in electronics. Back then, the idea of using quantum mechanics to build a computer that solves problems that would otherwise be beyond us was like science fiction. At Riverlane, our mission is to make this a reality, a decade sooner than previously imagined. We're doing this by building the operating system that makes quantum computers work. The Wright brothers repeatedly pushed planes off the sand dunes of Kitty Hawk until they finally discovered powered flight. But today, we use computer simulations to design new aircraft. But when we need to simulate microscopic systems, we hit a wall. Even if we turn the entire planet into a supercomputer, we could never simulate the way a new medicine works in the human body, or a new catalyst makes an industrial process more efficient. The equations of this microscopic world are quantum mechanical. So the only way to solve them is to build a quantum computer. Until then, for such problems, we are stuck in an age of slow discovery, not rapid design.
At Riverlane, we're building DeltaFlow, the operating system for error-corrected quantum computers. What operating systems fundamentally do is hide away the complexity so the user can concentrate on making amazing applications that are going to change the world. And what that means for quantum computing is that the operating system takes care of correcting the errors that the quantum computer throws up. And that's what DeltaFlow does.
It's important to understand the applications that end users want to run on quantum computers in order for us to be able to build the best operating system, because ultimately DeltaFlow has to deliver what they need. In order to do this, we're working with a number of industry leaders on different problems, like Rolls-Royce on designing better jet engines, or AstraZeneca on designing new drugs.
So you could ask, how hard is it to build a quantum computer? And the answer is, it's probably the hardest thing that we've tried as a species. Quantum bits don't want to live forever, and you have to use these maths around quantum error correction to actually solve that particular problem. So as we scale quantum computers from hundreds to thousands or even millions of qubits, we need to solve this error problem, and the error problem gets larger and larger. A simple estimate of solving quantum error correction on a single quantum computer for a single quantum computing clock cycle needs us to process the same scale of data as Netflix's global streaming network. We're making great progress in doing this. First, in a small way, then proving it can be done at the ever-increasing scale we need as part of DeltaFlow. Now, we can move from, is it possible, to how do we engineer it?
We've assembled world-leading experts from computing, science, and engineering. Together, we're doing something that has never been done before, building the operating system for quantum computers. This is a defining moment in history. It's a great privilege for Riverlane to be at the birth of this new era in computing.